Dear students, in continuation with the laws of motion, today we are going to discuss one more points, right? From starting onwards, if you observe what we are discussing laws of motion. In previous classes, we discussed about Newton's first law. Newton's first law is also known as law of inertia. We discussed, and before going to the Newton's second law, we discussed about the momentum. And in the last class, we discussed about momentum and we did one or two numericals. Clear? Now we are going to see the Newton's second law. Newton's second law. So we know that Newton's second law is the quantitative analysis. Newton's second law is quantitative analysis. So we'll try to understand what is Newton's second law. For example, here one car is there. One car. For example, it is moving with some speed 10 meter per second. How much speed it is? 10 meter per second. So when it is moving in this direction with 10 meter per second, I applied some force. I pushed. For example, if I am that much of strong, I pushed the car. So when I pushed, then you tell me this car will move with the same velocity or velocity will increase? Its velocity will increase. So here, for example, I will write 20 meter per second. Clear? That means when the force is acting on the body, the momentum is changing. Momentum is changing. That's what Newton's second law is saying. I hope you understood, right? When force is acting, then automatically there should be some change in velocity. When there is some change in velocity, then there is some change in momentum. That's what Newton's second law is saying. According to Newton's second law, the rate of change of momentum is directly proportional to the applied force. Is directly proportional to applied force. See here, I will write according to Newton's second law, the rate of change of momentum is directly proportional to applied force. See here, why I am saying it is directly proportional? Why? Because more force is applied, more change in momentum will be there. Less force is applied, less change in momentum. But according to Newton's second law, the rate of change of momentum is directly proportional to applied force. That means here F is equal to rate of change in momentum. What is the meaning of change in momentum? In the last class itself, we know what is the meaning of change in momentum. Change in momentum is nothing but delta P. So delta P by here rate of change. So rate of change is measured with respect to the time. So I will write here delta T. Very important formula. F is equal to delta P by delta T. I hope you understood, right? According to Newton's second law, the rate of change of momentum is directly proportional to the applied force. F is equal to delta P by delta T. So further, if you want to derive, see here, F is equal to what is delta P? Delta P is change in momentum. What is change in momentum? Final momentum minus initial momentum. So here it is final momentum minus initial momentum upon time. I will write delta T. So T2 minus T1. So final time minus initial time. So it will be the time difference. So again I will write here F is equal to what is final momentum? What is final momentum? Mass into velocity. So I will write here Pf can be written as m into v minus Pi can be written as m into u upon time difference. I will write it is t. Time difference I am writing it is t. So here F is equal to m. I will take common here, m is there, and here also m is there. So I will take m as common. So if I will take m common, so v minus u by t. V minus u by t. Now my question, what is v minus u by t? What is v minus u by t? You tell me. Tell me, what is v minus u by t? V minus u by t is called acceleration. Why? Because in motion chapter, we know acceleration is nothing but change in velocity upon time. What is acceleration? Change in velocity upon time. A is equal to v minus u by t. A is equal to v minus u by t. So here I will write, instead of v minus u by t, I will write F is equal to m into a. F is equal to ma. Very, very important formula. F is equal to ma. So here I will write F is equal to m into a. So SI unit. What is SI unit? SI unit of force. Mass is kg. Mass is kg. Acceleration. Acceleration is meter per second square. Acceleration meter per second square. It is also known as we can write, or it is N, Newton. Why? Because Newton only derived. That's why SI unit is Newton. 1 Newton is equal to 1 kg meter per second square. 1 Newton is equal to 1 kg meter per second square. So here is SI unit. So CGS unit, CGS unit. What is CGS unit? What is CGS unit? Kg means gram centimeter per second square. Gram centimeter per second square. It is also known as dyne. It is also known as dyne. Am I clear? Clear? What is Newton's second law? What is Newton's second law? The rate of change of momentum is directly proportional to the applied force. The rate of change of momentum is directly proportional to applied force. F is equal to delta P by delta T. Delta P by delta T. Again, we will use this formula. Very, very important formula, this one. Again, we will use it in the next class. So try to remember. That's why I put a box here. F is equal to delta P by delta T. And we know what is the meaning of delta P, right? So after that, I got F is equal to MA. MA is very, very important. MA is very, very important. F is equal to MA. And what is SI unit? SI unit is Newton. And 1 Newton is equal to 1 kg meter per second square. And CGS unit is dyne. Please make a note. We know F is equal to m into a. F is equal to m into a. So maximum we will discuss about these points only. F is equal to mass into acceleration. So now we have to understand that when a force is acting on a mass, then the mass should accelerate. Mass should accelerate. Why? Because if F is there, then absolutely A should be there. So when force is acting on a body, the body is getting accelerated. I hope you are understanding, right? The body is getting accelerated. For example, so here one ball is there. One ball is there. Correct? So here the ball of mass is given. Mass is equal to 1 kg. How much ball it is? Mass is 1 kg. So here I applied a force of 20 Newton. I applied how much force? It is 20 Newton. He will ask, find acceleration of ball. Find acceleration of ball. I hope you are understanding, right? Find acceleration of ball. I know what I know. F is equal to m into A. Correct? How much force is acting here? 20. Which is equal to how much mass is given? 1 into acceleration. So he is asking acceleration only. So directly you can write A is equal to 20 meter per second square. I hope you are understanding, right? You are understanding, right? How much acceleration is? 20 meter per second square. So we'll see one more question. See here, again we are seeing here one more ball is there, one more ball is there, and of mass m is equal to 5 kg. M is equal to 5 kg. And I applied a force of, for example, 10 Newton. How much force I applied? How much force I applied? 10 Newton. And he is asking that, what he is asking? Tell me the question. What he is asking? Find acceleration of ball. Clear? Just you make pause the video and try to solve within 1 minute. Clear? Now see. Solution. We know only one formula, that is F is equal to mass into acceleration. So F is equal to mass into acceleration. F is equal to mass into acceleration. So we'll write F is how much? 10 Newton. And mass is how much? 5 kg. 5 into acceleration. So here 5 is multiplying here. If you look at this side, it will be in denominator. So A is equal to 10 by 5. So A is equal to 2 meter per second square. So in this way, we can able to find out the acceleration of a given system. That means what I am trying to say is, when a force is acting on a body and the body should get accelerated. Body get accelerated. So one more question we will see how we can ask, for example. See here, again the same question we will solve in different way. So here he is saying that mass is 2 kg. Mass is 2 kg. Force is applied here. Force is applied, but he didn't mention how much force it is. Force is applied. And we observe that it is moving with an acceleration of A is equal to, for example, 2 meter per second square. A is equal to, how much it is? 2 meter per second square. So he is asking that, now what he will ask? Acceleration. Acceleration already is given. So in this, which one is not given? Force is not given. So he will ask, find force. Find force. So we know that F is equal to ma. F is equal to ma. So we can write force we don't know. Force we have to calculate. Mass is given. How much it is? 2 kg. And acceleration already is given. It is 2. So F is equal to 4 Newton. F is equal to 4 Newton. So in this way, he can ask any question. He may ask find acceleration, find force, or find mass also he can ask. So anyway, only one formula, that is F is equal to ma. With that formula, we will solve any type of question. Clear? I hope you understood, right? Now see here, up to now we discussed about when one force is acting, so we calculate the acceleration, right? But every time we will not ask one force. For example here, again the same ball is there, same ball, and for example mass is given, mass is 2 kg, mass is equal to 2 kg. Here two forces are acting. How many forces are acting here? Two forces. One force here, this one, for example 10 Newton, and one force here, this one is 20 Newton. 20 Newton. He will ask, find the acceleration and the direction of motion. Find the acceleration and direction of motion. Now you tell me, in this direction 10 Newton's force is acting. In this direction 20 Newton's force is acting. So body or the ball will move in which direction? towards right or towards left? Body or the ball will always move in the direction of the greater force. Body will always move in the direction of greater force. So here this 10 Newton and this 20 Newton. So body has to move in this direction only. But because in this direction greater force is acting. Clear? So now you tell me here it is 10, here it is 20. So we have to calculate the total force acting on the body. Total force acting on the body. How to find the total force? See here, one force is acting in this direction, 10 Newton, and one force is acting in this direction, 20 Newton. Correct? We know acceleration is a vector quantity. So force is also a vector quantity. So vector quantity means, I already told you in the last classes, vector quantity means it depends upon the direction. Now you tell me it is moving in this direction, so I will consider it is plus 10. It is moving in this direction, I will consider it is minus 20, which is nothing but F net. F net is nothing but the total force. F net is nothing but the net force or total force. So I will write here F net is equal to minus 10 Newton. Don't consider, sir, here minus 10 means less than 0. No. Minus 10 is not less than 0. 0 or minus or minus 2 in that case means no. Here minus represents the direction. How it is? So this one, see, we are saying this plus x-axis, correct? And we are saying this one is minus x-axis. So this force is acting in this direction towards the plus x-axis. That's why I consider this plus. And 20 Newton is acting in this direction towards minus x-axis. That's why I consider this minus. So net force is in the direction of the greater forces. So what is the net force direction here? Net force direction is in towards the negative. So here the minus represents that the net force is acting along minus x-axis. So here the ball is there here, and net force will be in this direction. How much it is? Only 10 Newton. How much it is? 10 Newton. How much mass is given? 2 kg. Mass is given as 2 kg. So now can we calculate acceleration? Yes, we can calculate. We know F is equal to ma. So mass is given as 2 kg, and force how much we got? 10 we got, and acceleration it is a. So acceleration a is equal to 10 by 2, which is equal to 5 meter per second square. So in which direction the body is moving? Plus x-axis or minus x-axis? Minus x-axis the body is moving. Very good. I hope you are understanding, right? So we will see one more numerical. So based on that, we will try to understand what is the meaning of force, how the force will act, and how to calculate acceleration, right? Now see this question. Ball is there. Of mass I will write m is equal to 2 kg. And here how many forces are acting? 3 forces are acting. How many forces? 3 forces. But 3 forces, one is along the x-axis only, right? Along the x-axis. Either it is positive or negative. X-axis only it is acting. So now see here, in this direction, along the positive x-axis 5 Newton and 2 Newton is acting. Along negative x-axis how much it is? 3 Newton is acting. So he is asking that find the acceleration and the direction of motion of the ball. You can write here find acceleration and direction of motion of ball. Direction of motion of the ball is asking, right? So now we can calculate easily, same manner. See, these two are in the same direction only. If the two forces are acting in the same direction, so what we can do? We can add directly, right? So why? Because this one also moving along the positive x-axis and this one also moving along the positive x-axis. Both are moving the positive x-axis, so I can add. So here how much it is? It is 5 and it is 2. Total will be 7. So here ball is there here. In this direction, I got 7 Newton of force. And in this direction, along negative x-axis, how much it is? It is only 3 Newton. Now you tell me, which direction the greater force is there, along positive x-axis or negative x-axis? Positive or negative? Tell me. Along positive x-axis, right? Why? Because in the positive x-axis, 7 Newton is acting. So the acceleration is also in the direction of the greater force. Acceleration also in the direction of greater force. So in this direction, acceleration will be there. So if you want to find F net is nothing but the total force acting on the ball. Total force acting on the ball. So what to write? So this one is moving towards the positive x-axis. I will write this plus 7. And this one is moving towards the negative x-axis. I will write this is minus 3. So here F net is equal to 7 minus 3. It is 4. F net how much you got? 4 Newton. Clear? Units are very important. Even though I forgot, you should not forget, right? F net is equal to 4 Newton. So what he is asking? He is asking acceleration. We know F net is equal to mass into acceleration. F net we got 4. Mass how much it is? 2 kg is given. So 2 into acceleration. So A is equal to 4 by 2, which is equal to 2 meter per second square. 2 meter per second square. So I hope you understood, right? But clear? We discussed about Newton's second law. In Newton's second law, we found the relation between the force and acceleration. We got F is equal to ma. According to Newton's second law, the rate of change of momentum is directly proportional to the applied force. Rate of change of momentum is directly proportional to the applied force. From that, we got F is equal to ma. So when a force is acting on a body, then body should accelerate. So body should accelerate, correct? So we will see one more example and after that we will close. Try to understand. Very important example, right? See here, ball is there and in this direction 5 Newton is acting. How much it is? 5 Newton along positive x-axis. Here also 5 Newton along negative x-axis. 5 Newton positive x-axis, 5 Newton negative x-axis. Now you tell me, body will accelerate. Body will accelerate or not depends upon the net force acting on the body. Body will accelerate or not depends upon the net force acting on the body. So I will calculate net force. So F net can be written as this 5 is moving towards the positive x-axis. I will write this 5 and this 5 is moving towards negative. So it is minus 5. So this F net plus 5 minus 5 will be 0. F net is equal to 0. So if F net is equal to 0, we know F net is equal to mass into acceleration. Mass into acceleration. So F net, how much I got? 0 I got, which means 0. So A is equal to 0. A is equal to 0. That means if net force acting on the body is equal to 0, the acceleration produced by the body is also 0. That means the body is at rest. That means here body is there. Here one hand one is pulling. So greater force means I will move. Correct? Towards the greater force I will move. But if the forces are equal, I cannot able to move, right? I will be stable. So the same example here. I hope you understood, right? Thank you.